This is the third video for implicit differentiation, and this is the applications, and there's going to be 3 application problems. And what I have here is a circle. It's x squared plus y squared equals 25, and if you recall, that is a square with a center at 0, 0 and a radius of 5. So here I want to find the slope of the circle at the point 3, negative 4. So if we went over here, 3, negative 4, we want to find the slope of the circle at that point. We're going to go one step further. We're going to find actual tangent lines. So we're going to find the equation of the tangent line after we find the slope. Okay, so the tangent line right here is going to be y minus y1 equals mx minus x1. And we need a point and a slope, and we already have our point xy, so we're going to throw that in there. But now we have to find the slope, which is going to be our derivative. So let's do the derivative of this circle. So it's differentiation. It's implicit differentiation because our x's and y's, and we differentiate both sides. So it's going to be 2x dx plus 2y dy equals 0. And then I have terms here, so I can now go right off the bat and divide by dx. Thanks for playing. So I have 2x plus 2y dy dx equals 0. I'm going to move the 2x over on the other side here, so I have 2y dy dx equals a negative 2x. And then here I'm going to divide by 2y, so I have dy dx equals negative 2x over 2y, and the 2's will cancel out, so it's negative x over y. So I just found the derivative, but I now want you to actually put in the point to find what the slope is at the 3, 4. So this is a little bit different because you guys are used to just putting the x in, but now you can do the y. So when I throw the 3 in here, I have a negative 3. When I throw the negative 4 in there, I have negative 4. So the slope is 3/4. And if you look at our picture here, it kind of shows you that the slope is 3/4, and there's our tangent line right here that we're looking at. So I know the slope is 3/4. So I'm going to go ahead and throw this in my tangent line. So I have the point y minus a negative 4 is y plus 4. That's a 4, sorry. Y plus 4 equals 3/4 x minus 3. So y is going to be 3/4 x minus 3 minus 4. So right there is the equation of that tangent line. And you used implicit differentiation to find it. Okay. Now let's try another one here. We're going to find the equation of the tangent line for this function. And I don't have a picture for this one, but we still can do this. The equation of the tangent line is going to be y minus y1 equals mx minus x1. And again, I already have my point, xy, so we're good. So now we got to find the slope by taking the derivative. So let's take the derivative of this implicitly. So it's going to be 2x dx minus 3y squared dy equals 2 dx. Go through and divide through by dx because I have all terms. I don't have to worry about anything else. And this is nice. Thanks for playing. So I have 2x minus 3y squared dy dx equals 2. Now I'm going to solve for dy dx, and the easiest way to do this is to take this whole term right here, this negative right with it, and move that all over to this side, and then move the 2 over here. So I end up with 2x minus 2 equals a 3y squared dy dx, and then we're just going to divide through by the 3y squared. So I have dy dx equals 2x minus 2 all over 3y squared. Okay? Now we're going to plug in the point, the x and the y. So again, you have 2 times 4 minus 2 over 3 times 2 squared. So that's 8 minus 2 is 6. 4 times 3 is 12. So the slope is 1/2. At the point 4,2, and then we just plug it into our formula. So I'm going to bring that down here. So I have y minus 2 equals the slope of a half, x minus 4. So I have y equals a half, x minus 4 plus 2. And there is the equation of the tangent line. Let's try the very last problem here. And this one is got a little bit more to it. And here I have this function. In the blue here, this is the equation for it. It is x cubed plus y cubed minus 9xy equals 0. And what they want us to do is show that the point 2, 4 lies on the curve. Okay? Find the tangent and the normal to the curve at that point. So first of all, to show that the point 2, 4 lies on the curve, that means it's got to work in this equation. So if I put this 2 in the x spot and y in the 4 in the y spot, if I plug it in here, it should equal 0. So let's see if it does. So I have 2 cubed plus 4 cubed minus 9 times 2 times 4. And 2 cubed is 8 minus 4 cubed minus this. All does come out to be 0. So it does check. 0 equals 0. So I know that this point does lie on the curve because it works on that equation. Now they want us to find a tangent at that point, which is fine. I have no problem doing it because right here is the point 2, 4, now that we know it's on the curve. And the tangent line we've been doing, but the normal curve I want you to know is the normal curve is perpendicular to the tangent line. So after we find the slope, we have to do the negative reciprocal. Okay, so basically it's just one extra step that one we've been doing. So we have the equation of the tangent line. So let's kind of set it up here. So here's the tangent line. And you know the tangent line is going to be y minus y1 equals m x minus x1. And the normal line is going to be the same thing, but when I put my equation in, I'm just going to change the slope to the negative reciprocal. So I'm just setting it up right now. So let's do our work here. First of all, I have to do the derivative of this function right here so that I can find the slope. So let's do the derivative. So I have 3x squared dx plus 3y squared dy. Now here, I just want you to see what you got here. You have the product rule. And I'm going to say minus 9, and we've done this xy before, f and g's. Remember it was x dy plus y dx, or if you need to do it again, say f is x, f prime is dx, g is y, g prime is dy. So it's x dy, f prime g, excuse me, y dx plus x dy. So we're going to write it here, y dx plus x dy, because that's the product rule. And it's going to equal 0. Now, again, if you don't have all terms, I want you to multiply through first. So I have 3x squared dx plus 3y squared dy minus 9y dx minus 9x dy equals 0. Now go through and divide through by dx's, so the dx's will of course disappear. So this is gone. Thanks for playing. This is gone. So I have 3x squared, okay, plus 3y squared dy dx minus 9y minus 9x dy dx equals 0. So again, we're going to isolate the dy dx's. So I'm going to basically move the dy dx's to this side. It doesn't matter which way you do it, but as long as you get them on one side. So I have 3y squared dy dx minus 9x dy dx, and we'll move everything on the other side, equals, and then this will turn to a positive 9y and a negative 3x squared. And then I'm going to factor out the dy dx on this side. So you kind of do the same thing over and over again. So I got 3y squared minus 9x equals 9y minus 3x squared. and then we're going to go through and divide through by that. So I have dy dx equals 9y minus 3x squared all over 3y squared minus 9x. Okay, so we found the derivative. Now let's plug our point in, and our point is the point 2, 4. So I have 9 times 4, okay, minus 3 times 2 squared all over 3 times, well, you know what we can do? We can make this a little bit easier. Every single one of those terms we can divide by 3. Wouldn't that make it nicer? So I really have 3y minus x squared. Let's do that. All over y squared minus 3x. And again, the reason why I did that, it makes the math a little bit easier because every single one of these terms can be divided by a 3 and make it a little bit nicer to use. So I have 3 times 4 minus, yeah, the math's a little bit nicer, 2 squared, all over 4 squared minus 3 times 2. So that comes out to be 8 over 10, or 4/5, which I'm kind of happy about because the tangent line looks like it's got a positive slope. So now if I put this in here, I have y minus 4 equals 4/5 x minus 2. So our tangent line is y equals 4/5 x minus 2 plus 4. And that's kind of squished in there, so let me highlight that for you. So there's the tangent line. When I do the normal line, all I have to do is change my slope to negative 5 over 4. So the tangent, the normal curve is going to be y equal, excuse me, not normal curve, but the normal line is going to be negative 5/4 x minus 2 plus 4. So there is our normal line. So just remember the normal line is perpendicular to the tangent line, so you know the slope are negative reciprocal. Okay, we finished our examples or applications for the implicit differentiation.